Okay, today we're looking at study guide number 2. Now let's see what we have going on here. A parking garage in a large city. The charge for parking consists of a flat fee of $2.50 plus $1.25 per hour. Write a linear function to model the cost for parking, P of t for t hours. So P of t equals the flat fee, $2.50 plus $1.25 times the time. We want to evaluate P of 1.8. So P of 1.8 is simply $2.50 plus $1.25 times 1.8, which comes out to be $4.25. And interpret the meaning and context of this problem. Well, it will cost $4.25 to park for 1.8 hours. Determine the domain and range of the function from its graph. So we're looking for the domain and the range. Okay, as you recall, the domain is our x value. So what is our leftmost x value? Looks like it's -3 here. However, note we have an open circle here, so it's not included. And then we have the arrow going on, so it's to infinity. Okay, now our range, that's our y values. What is our lowest y value? That would be 1, which is included. And again, it goes all the way up to infinity. So 1 to infinity. Write an equation for a function that has a graph with the given characteristics. Parent function is y equals the absolute value of x. It has been shifted 2.3 units to the left, then shrunk horizontally by a factor of 1/2, and finally reflected across the y-axis. So it gives us this in the order to do it. So if I take and shift it 2.3 units to the left, I have y equals the absolute value of x plus 2.3. To shrink it horizontally, I multiply my x values by a factor of 1 over a, in this case 1/2, so 2. So my second step would be y equals the absolute value of 2x plus 2.3. Since it's horizontal, I just multiply the x values. And lastly, are reflected across the y-axis, which means I take the negative of y, so I have y equals negative absolute value of 2x plus 2.3. Okay, now we have the function given by y equals f of x shows the value of $5,000 invested at 5% annual interest compounded continuously, X years after the money has originally invested. Find the average amount earned per year between the 10th and 20th year. So here's my 10th year, which was 8244, and my 20th year. So I simply take 13,591 minus 8,244 and divide it by the 10-year difference. And I end up with $534.20. Then it says to find the average earned between the 5th year and the 10th year. Year 5 was 6,420. Year 10 again was 8,244. Take my difference, 8,204, 4 minus 6,420. And in this case, it's 5 years. And when I average that out, I get $364.80. And based on these answers, does it appear that the rate at which the income increases is increasing or decreasing with time? Well, the average rate from year 5 to 10 was 364 and change. The average rate from the year 10 to 20 was 534. So it appears to be increasing. Okay, now we're going to look at the regression model. Table gives the wind speed y in miles per hour of a hurricane versus the barometric pressure x. Get a partial list of data from the graph. Use the data in the table to find least squares regression line, round your slope to 2 decimal places, and y-intercept to the nearest whole unit. Then use the model in part A to approximate wind speed of a hurricane with barometric pressure of 850 millibars. So what we need to do is put this into our calculator. Hitting stat, and we want to edit. And then for our x values and our y values, we key each one in. So we go to line 1 and we put our x values in. And we're done with that. We go to line 2 and put our x values in. Then we hit stat again. And now we want to calculate. And we want to calculate linear regression, which is number 4. After we do that, it'll give us our equation, or it'll give us our a and b. And the equation turns out to be y equals negative 1.22x plus 1,275. Plugging in 850 millibars, I get y equals negative 122 times 850 plus 1,275, which is 238 mile per hour winds. Hopefully we never see that. Okay, moving on to the next one. The graph of the function y equals f of x is given. Give the graph of y equals negative f of x plus 2. So we have two things happening here. This is reflect across x, and this is up 2. Now, if you recall, vertical shift is last. So we reflect across the x-axis. So this negative 1, 0 would stay the same. This point here, which is 2, 3, would become 2, negative 3. And then this point here, which is 4, 1, would become 4, negative 1. And that is our reflection. Y equals negative f of x. Now I need to move that up 2. So this point, negative 1, 0, would become negative 1, 2. And this point, 2, negative 3, would become 2, negative 1. And this point here, 4, negative 1, would become 4, positive 1. And that would be our final drawing. This would be y equals negative f of x plus 2. Use interval notation to write the open intervals over which the function f is increasing, decreasing, and consistent. So where is it increasing? That's this section right here. X equals 2 to infinity. Okay, B, where is it decreasing? Well, that's this point here. X equals -3 to -2. And where is it constant? Well, that's this part here, -2 to 2. That's it. Okay, next, write an equation for the graph below, which has been obtained by carrying out a series of transformations on the graph of y equals x squared. Okay, so what do we see here? We see a vertex of 2, -1. And it doesn't look like it's been stretched or shrunk at all. So let's see, how do we get this to become that? What was that order of operation? Remember, vertical translation is last, and horizontal translation is first. And that leaves it's like we flip it over the x-axis, so reflection is second. So what do we do first? Horizontal transformation. I move in it right 2 units. So that gives me y equals x minus 2 squared. Next, I'm reflecting across the x-axis, which we've done already, which gives me negative x minus 2 squared. And then I'm moving it down 1 unit, which will give me y equals negative x minus 2 squared minus 1. And that is the final equation. Okay, I warned you about this. Graph the function f of x equals 0.25x cubed plus 1.3x squared minus 2x minus 5. Recall that this 0.25x cubed, you simply key it in as 0.25x, hit that caret button, 3. Once we do that, we want to find the minimum and the maximum. So again, once you put it in there and you graph it, let's do that, see what we got here. So I have 0.25 x cubed plus 1.3 x squared minus 2x minus 5, and graphing it. And I've got a dimension error, so let's see. There we go. So looking at my graph of this, goes up like this, and comes down like this, and goes back up. So here is my max, and here is my min. So let's do the maximum first. I do second trace, and it says left bound, pick a point over here. And it says right bound, pick a point here. Then you hit enter, and you should get -4.115. It says 3 decimal places, comma, 7.823. Follow the same procedure for the minimum. Left bound here, right bound here. Enter again. And we should get 0.648 negative 5.682. And that is our relative minimum and maximum. Next up, find the indicated function and write the domain in interval notation. So we have p of x is x squared plus x, and q of x is square root of 2x plus 4. So it's simply x squared plus x times the square root of 2x plus 4. Now we need to think about the domain. What about it? Well, this part here is all reals. This part here, however, recall that 2x plus 4 must be greater than or equal to 0. So 2x must be greater than or equal to negative 4. So x must be greater than or equal to negative 2. So we have negative 2 to infinity, and negative 2 is a solution. For the function f of x equals x squared minus 3x, find the difference quotient, f of x plus h minus f of x. So what is f of x plus h? Well, that'll be x plus h squared minus 3 times x plus h. We have x squared plus 2xh plus h squared minus 3x minus 3h. Okay, now we're looking for the difference quotient here. So we take f of x plus h, which is x squared plus 2xh plus h squared minus 3x minus 3h minus x squared minus 3x all over h. Need to distribute that minus, so I have x squared plus 2xh plus h squared minus 3x minus 3h minus x squared plus 3x all over h. So I have a positive x squared and a minus x squared. Those cancel each other out. I have a minus 3x and a positive 3x. Those cancel each other out, and I end up with 2xh plus h squared minus 3h over h. Divide out the h, and I get 2x plus h minus 3. Okay, last one. For the functions m of x equals x minus the square root of x minus 2, and n equals x plus 3, find the composite of m and n of x and write the domain of m and n in interval notation. So m, the composite of m and n of x is simply m of n of x, which means I plug in n of x for every x in m. So I get the square root of x plus 3 minus 2, which is the square root of x plus 1. Okay? Then looking at this, I know that x plus 1 has to be greater than or equal to 0. So x has to be greater than or equal to 1. So 1 is included, and I'm going all the way to infinity. And that finishes it. All right, so good luck.